Okay, Assalamualaikum and good day. So, today we will look at a new chapter which is Fourier series. Okay, Fourier series. First, we will look at the periodic functions here. Okay, a periodic function is a function that repeats its values in regular intervals or periods. Okay, repeats its values in regular intervals or periods. Okay, that is, for example, trigonometric functions. This is an easy example of a function that is repeated regularly. Okay, and by nature, sin x and cos x are periodic functions. Why? Because as you can see, for example, for this one, fx equal to sin x, the graph is always going to be this way. That means here, even if we continue on the left side, the graph should be like this. This one is actually pi, so that means here is negative pi. Okay, so next, a function fx is said to have a period 2l or to be periodic with period 2l if for all x we have fx plus 2l equal to fx. Okay, you need to remember that one period is equal to 2l. Okay, one period is equal to 2l, where l is a positive constant. Okay, positive, and the least value of 2l must be greater than 0. Okay, since l is positive, by right 2l must be greater than 0. This is what we call as the least period, or simply the period of fx. That means our fx should be periodic. That means it's the function repeated at certain interval. Okay, let's look at the example. So for the first one, we have a fx equal to sin x, which means here we need to actually determine the period first. So the period is actually the time when this curve going back to its direction here. That means here the period is actually 2 pi. Okay. Since sin x is equal to sin x plus 2 pi, that means it repeats the figure, okay, the form, and it is also the same as sin x plus 4 pi. It goes on. Okay, so therefore here we can conclude that sin x has a period of 2 pi. Okay, so next, b, fx equal to x when x is between negative 1 to 1. Okay, as you can see here, this one should be our negative l, x until l. Okay, so 2l is actually the upper boundary minus the lower boundary. That's why we have here 2l. Okay, so right now, what is the upper boundary here? The upper boundary here should be 1 minus the lower boundary is negative 1. So here we have 2l is equal to 2. As you can see here, fx is equal to fx plus 2, where period is equal to 2. That means it repeats the form. Okay, bentuk dia repeats the function in the interval of 2. That means from negative 1 to 1, 1 to 3. And here from negative 3 to negative 1. That means the interval here, the period is equal to 2. The same goes here. The period is 2. Okay, here the period is also equal to 2. Okay, for the next one, C, we have fx equal to k. That means this is a constant. A constant has any positive number as period. We just need to let something there. So let's say here is x and here is y. We have fx equal to k. Let's say this is where k is. So here the line should be this. Okay, so here is fx equal to k. Okay, next, fx equal to cos x. Okay, this one is a graph that has been modified actually. this is not the real fx equal to cos x, but it actually limit to the certain interval. As you can see here, the interval that we have is actually from negative pi over 2 until pi over 2. As I mentioned earlier, this should be our L and this is our negative L. And how do we actually calculate for 2L? 2L is equal to upper boundary pi over 2 minus the lower boundary. Okay, so 2L is equal to pi. That's why period is equal to pi. Okay, the graph for cos x should be like this, from negative pi over 2 to pi over 2. And then since it repeats in the interval of pi, so from pi over 2 to 3 pi over 2 is still pi. And negative 3 pi over 2 to negative pi over 2, the interval is still negative pi. It repeats the form. Repeat bentuk yang sama. So this would be the form then. The shape. Okay, the shape. The same shape. Okay. Repeat the same shape. Okay. Let's say negative 3 pi over 2. Another pi here. Sorry, it should be positive there. No, negative. Okay. Here pi. That means until negative 5 pi over 2. And it repeats the same shape. The same goes here. If we have 5 pi over 2, it repeats the same shape. Okay. Until infinite. Okay. Next, for the last one, we have this function. Actually, there is a value here. This one is actually 1. This one is 2. Okay, 3, 4, and 5. And we have here 6. Okay, let me write this first. Negative 1, negative 2, and negative 3, and then negative 4. Okay, we need to create actually a function to determine the piecewise function for this periodic function. Okay, the period is from 0 to 2. From 0 to 2, that means 2L is equal to 2 minus 0, which is 2L is equal to 2. Okay, next. Okay, fx here, it repeats from, as you can see here, from 0 to 1 and 1 to 2. So here, we have 0x, x between 0 to 1, and x between 1 to 2. So what is the function here? Okay, this one is actually equal to 1. So this straight line, a linear function, is actually fx equal to x. Because when x equal to 1, y equal to 1. Okay, and then next, from 1 to 2, it is a constant function, which is 1. Okay, so this is the piecewise function that we need to construct actually. Okay, next. Okay, wait a second. Okay, in example 3.2, we have here graph each of the following periodic function. Okay, this one we have fx equal to 3 for x between 0 to 5 and negative 3 between x negative 5 to 0. So here, that's why here it has been drawn with the scale of negative with a scale of 5. That means 0 to 5, 5 to 10, 15 to 20, and here negative 5, negative 10, negative 15. Why? Because we refer to these intervals. Okay, so the period would be 2L is equal to, as I mentioned earlier, upper boundary minus lower boundary. So you need to be careful. Okay, which one is the upper boundary? The biggest value is L, 5. So this is the upper boundary. And the lowest and the smallest value is negative 5. So negative 5 is the lower boundary. Here we have 2L is equal to 10. As you can see here, period equal to 10. Okay, that means it repeat the same shape form. Okay, in the interval of 10. Okay, between negative 5 to 0, the graph is at negative 3, a straight line. Okay, between 0 to 5, it is a straight line of 3 from 0 to 5. Okay, it repeats the same shape. That means repeat the same again. Okay, bentuk dia first half adalah this one, this area. Okay, we just need to repeat the same shape again. That means here it will be, okay, negative 5 ke kosong. Negative 5 to 0 is negative 3. So 5 to 10 is also negative 3. And then it repeats again. The next one should be here. And then repeat the same shape again. Okay, it start from negative 3 and then here should be 3. And for the one on the left, you need to reverse a bit. So that means we start here is for negative 10 to negative 5 is y equal to 3. And from negative 15 to negative 10, y is equal to negative 3. Okay, next, fx equal to sin x when x between 0 to pi and 0 from x for x between pi to 2 pi. Okay, so right now, period is equal to 2L is equal to upper boundary 2 pi minus lower boundary 0. So we have 2L is equal to 2 pi. That's why the period is 2 pi. So from 0 to pi, we just graph it. We have this form. Okay, this one should be 1 actually. Okay, and then from pi to 2 pi, it should be a straight line here. Why? Because it is equal to 0. Okay, and then the period is actually 2 pi. Okay, that means it repeats the same shape for every 2 interval of 2 pi. So from 2 pi to 4 pi, and then for the axis on the left, it should be here. Sorry. It should just be until here actually. To pi. That means the shape is actually the curve straight line. So we repeat the shape, the curve, and straight line. For the one on the left, you should start from the straight line, the curve. That means straight line and the curve there. Okay, the same goes here. Let's say we have negative 3 pi. And here is negative 4 pi because this would make an interval of 2 pi. So the shape should be 0 and then a curve. Okay, so the third one, okay, the last one here, we have fx equal to 0 when x between 0 to 2, 1 when x between 2 to 4, and 0 when x between 4 to 6. First, just sketch the graph. That means we have here between 0 to 2, it is equal to 0. Here, the straight line here is 0. And then 2 to 4, it is a straight line at y equal to 1. And then 4 to 6, it is a straight line here. Okay. Where y equal to 0. Okay, the period here should be, as I mentioned earlier, upper boundary is 6 minus the lowest boundary. That means 0. So 6 minus 0, our period is actually 6. That means the same shape graph will occur in the interval of 6. Okay, we will draw the same graph in the interval of 6. Okay, that's why here is 12. And here, for on the left, it should be until negative 6. Okay, because the period is actually equal to 6. 2L is equal to 6. Okay, one period is equal to 6. So right now, we just repeat the same shape again. The thing is just that 0, 1, 0. So that means here should be line at 0 and then 1, 0. Let's say you want to have another one. That means here is 12 until 14, 16, and then 18. Because this is still a period of 6. We just continue on. Okay, it start from 0, 1, and 0 back to 0. So 0, 1, 0. Okay, the next one on the left, it should start from the right one. So it should be 0, and then 1, 0. And then here, let's say we want to extend. We have here negative 8, negative 10, and negative 12. Okay, so we just start from the right one. So 0, 0. Okay, here. And then 1. And then back to a straight line at 0. Okay, I hope you have a glimpse on how to sketch a periodic function. Thank you, class. Assalamualaikum.